بسم الله والصلاة والسلام على رسول الله. Assalamu alaikum wa rahmatullahi wa barakatuh. Here's Ameen Ammar from the patch 2027, and today I'll be explaining the renal clearance for the renal unit in simple words, and I hope you find this useful. So, starting with the definition of the renal clearance, sorry, the definition says that the renal clearance is the volume of plasma from which a substance is completely cleared in the urine per unit time. Now, by understanding this definition, we will be able to find the clearance in simple mathematical calculations, even though without memorizing the actual formula for the clearance. How does that possible? How is that possible? We will see. So I have made this simple drawing to simplify things and to make things easier. We have three vessels here, or three tubes. The first tube corresponds to the blood that is coming toward the kidney, the inflow of the plasma to be filtered in the capillaries and then to be outflowing back to the body. At the same time, we will be having the urine flow through which the filtered substance or the excreted substances are being excreted out of the body. So we have the plasma inflow, we have the plasma outflow, and we have the urine flow. Clearance, we say that it is the volume of plasma from which a substance is completely cleared in the urine per unit time. This means that we are measuring this volume of plasma from which the same volume had a substance X with a concentration of X also before being filtered, but now this X substance is being filtered completely in the urine, so the remaining or the this amount of plasma is now totally free of substance X. So how can we measure this volume of the plasma? Let's put some numbers and things will be easy and clear. So here we have the inflow of plasma. Let's say that we have a concentration of 2 mg of the substance X, 2 mg of the substance X for each milliliter of the plasma inflow. This plasma inflow is reaching the filtration side and is being filtered from the substance X. So the substance X will be excreted out in the urine in a concentration that we will determine in a few seconds, and the free plasma is being returned back to the body. So let's say that the concentration of the same substance X in the urine is 4 mg for each milliliter. And assuming that the renal plasma flow, the urine flow equals to 10 ml for each minute. By knowing the urine flow and the concentration of the substance in each ml of the urine, we can determine the amount of the substance that is being excreted in the urine for each minute. It's simply by multiplying the 4 mg for each ml by 10 mLs, we will have that, or we will find that 40 mg of the substance X is being excreted in the urine for each minute. So this is the amount of the substance that is being excreted in the urine. If we want to take this amount and the exact same amount, and we want to return it back to the plasma, the question is how many mLs of plasma are needed to hold this exact same amount of the substance X. So if we say that for each ml can hold a total of 2 mg of the substance X, so for a plasma to hold a 40 mg of the substance X, we need 40 divided by 2, we need a total of 20 ml of plasma to hold this amount of the substance. So if we removed the 40 ml in the urine, that means that this 20 ml of the plasma is now completely clear of the substance X. So just to summarize and to correlate between the calculations that we made and the actual formula for the renal clearance. In our example, we say that if the filtration rate equals to 10 ml per minute and if the urine concentration of the substance equals to 4 mg and the plasma concentration of the same substance equals to 2 mg per ml, and we want to know, or we want to calculate the renal clearance of the substance X, we first started by calculating the amount of the substance that is being released in the urine, which equals to the urine flow rate multiplied by the urine concentration of the substance. 10 multiplied by 4 equals to 40 mg per minute. And then we divided this by the plasma concentration of the substance, which is 2 mg per ml. And this gave us the clearance rate, which was 20 ml for each minute. So we can put the variables in one equation in which the flow rate multiplied by the urine concentration will equals to the plasma concentration multiplied by the clearance rate. Putting the clearance rate on one side of the formula, we have to divide by the plasma concentration on both sides. So we will end up having the clearance rate equals to flow rate multiplied by the urine concentration of the substance divided by the plasma concentration of the substance. By applying this to our example, we found that the clearance rate of the substance X was 20 ml per minute.